We'll start this lesson off by quickly reviewing some traditional storage options. With traditional physical servers in the data center, just about every server has local storage. That local storage, or the disk inside the server, are called DASD, or directly attached storage devices. In some cases, those disks are also attached in a storage drawer and are called JBOD, or just a bunch of disks. Optionally, those disks can be provisioned out using RAID groups and SCSI LUNs. But most enterprises have moved to SAN or NAS storage. Those are the two shared storage options traditionally used in the data center today. SAN storage, or storage area networks, use either iSCSI or fiber channel technology. And the SAN storage, while shared amongst many servers, appears as a local drive. With the NAS storage, your storage appears as shared network drives. Protocols in use for NAS are NFS, the Network File System, or SMB, which stands for Server Message Block. SMB is what's used by Windows file servers for file sharing today. Now, when you start using virtual storage with Hyper-V, you still need physical storage of some kind. These forms of storage don't just totally disappear. However, all servers that are virtualized will instead use virtual storage, and that virtual storage for each virtual machine will be stored on one of these forms of traditional storage, local, SAN, or NAS. So what is virtual storage? Let's find out. When you create a new virtual machine, that virtual machine's hard drive is virtualized and turned into a file on the Hyper-V host storage. I'll show you that in a minute. But there are so many different benefits to using virtualization. When it comes to virtualizing storage, you'll gain benefits around hardware independence, which allows you to move a virtual machine from one host using one type of storage to another host using a completely different type of storage without the virtual machine ever knowing the difference and without having to make changes inside the virtual machine to the operating system or the applications. With this new virtual machine portability, you could export a virtual machine from a Hyper-V host to an external disk, give it to another company around the world. They could import it, and immediately they could run all the applications and access all the data inside the virtual machine, operating system, and applications. You'll gain easier backup and replication. Backup software and disaster recovery replication software can back up or replicate just the blocks of the virtual disks that have changed. This will save you time, storage, bandwidth, and make restoration of virtual machines in the event of an outage or data loss quicker than ever before. You'll gain cloning, where you can copy one virtual machine into another and instantly duplicate it. This is great, for example, if you want to clone, let's say, a production application into another virtual machine and make it a development application or a development virtual machine without any operating system install, database configuration, application install, or config. You'll gain snapshots. I'll demonstrate snapshots in just a minute, but what they do is they take a point-in-time picture of a virtual machine that you can then roll that virtual machine back to that point whenever you need, and then even forward again to where it was in the beginning. This is excellent for you if you want to test a configuration change, an application upgrade, or an operating system upgrade. In fact, backups use snapshot technology so that they can back up the virtual machine as it is today with zero downtime. And finally, you'll gain thin provisioning, which is where your virtual disk that you create can be sized at one very large size, but not actually use that amount of space on the physical local disk until the operating system and applications inside the virtual machine need to use it. In other words, you can have an empty shell of a virtual machine disk file not take up but a few megabytes on the physical disk, but to the virtual machine's operating system inside, it thinks it has, let's say, a 100 gigabyte disk file. As I said, the virtual machine disk files are actually on the host Hyper-V server. In the case of Windows Server 2012 Hyper-V, they're now called .vhdx files, or just VHDX files, and they're stored on the physical storage. Now, before we jump over to the Hyper-V lab, let's first explore the three different types of virtual disks that you can create. They are fixed, dynamic, and differencing. With a fixed virtual disk, it is what it is at the time that you create it. A fixed virtual disk would be used for your production servers because it's going to offer you the best performance. So when you create a new fixed virtual machine disk file, all of the disk space is allocated on the physical disk at the time that you create it. The second type of virtual disk is dynamic. This is a thin provision virtual disk where the disk space on the physical disk isn't used until the virtual machine actually needs it. I use dynamic disk on all the test servers that I create because honestly, I don't need the performance and I don't need a bunch of test servers eating away all the disk space on my physical disk. The third type of virtual disk is differencing. A differencing virtual disk just contains the changes from a master or parent virtual disk that you specify. Thus, if you created a new virtual machine with a differencing disk based on an existing Windows Server parent virtual disk, the differencing disk could be quite small, as it just contains the changes that you make to the server since the master virtual disk was created. In other words, differencing disks, while not used a lot today in production, are a great way to save on disk space when you have multiple virtual machines that all have similar operating systems and applications. With VHDX being the new virtual disk format of Windows Server 2012 Hyper-V, let's spend a little bit more time discussing it. When you go to create a new virtual hard disk, you can create the old format VHD from Windows Server 2008 or the new format VHDX. I would always recommend using the new format because it offers so many benefits unless you have some need for backward compatibility. For example, let's say that you needed to share virtual machines with an older Windows Server 2008 Hyper-V host. Now let's talk about the benefits of the new VHDX format. It has so much more to offer. It has larger storage capacity than the older VHD format, and it also has the ability to prevent data corruption. The main features of the new VHDX format are support for virtual hard disk storage capacity up to 64 terabytes in size. It protects you against data corruption during power failures by logging updates to the VHDX metadata structures. The improved alignment of the virtual hard disk format allows it to work better on large sector disks, and it offers larger block sizes for dynamic and differencing disks, which allows those disks to meet the needs of the workload. In addition, VHDX disk can store custom metadata about a file that a user might place inside the virtual machine disk file, such as operating system version or patch information. And then finally, the efficiency of the VHDX format results in smaller file sizes for the virtual machine disk and allows the underlying physical storage to reclaim as much space as possible. This is also known as trim, and to take advantage of trim, you need to have directly attached disks which are trim compatible. Besides the benefits of the new VHDX format, there's a number of new storage features in Windows Server 2012 Hyper-V. You can now store virtual machines on USB 3 storage, which is going to give you much higher performance than ever before for a removable device. And then there's virtual fiber channel support. With virtual fiber channel, you can connect to a fiber channel SAN from within a virtual machine. This allows your existing fiber channel investment in fiber channel SAN to support the virtualized workloads. Now let's go over to the lab and work on some virtual storage tasks. What we'll do is create some snapshots, revert snapshots, identify the virtual disk files on the Hyper-V host for your virtual machines, and then create new virtual disk files and attach those to a VM. So with that, let's get started. Here we are over in our Hyper-V server, and the first thing we said we wanted to do was to create a snapshot. There's a couple different ways to create snapshots. The first way is just to select a virtual machine and then go down here to the virtual machine actions and click snapshot. And there for just a second on the right hand side it said taking snapshot, and now we have a new snapshot created. So if I select the snapshot, notice it says the date and time that the snapshot was taken. I could go over here and there's some snapshot actions. For example, I could apply the snapshot, which would actually restore this virtual machine back to where it was before when the snapshot was taken. I could rename it, so give it a better name, a more descriptive name. I could delete the snapshot, or I could delete that snapshot and all the snapshots underneath. I can also go over here and I can right click on the snapshot, and here I can do the same types of actions. So let's go ahead and open up this virtual machine console, and I'll go ahead and log in. So here I am in the virtual machine, on the virtual machine console of this Windows 2012 host. And notice there's a folder here called Look at Me that I created. If I open up that folder, it is empty. let's go ahead and just right click and let's create a file inside there. And I'm going to just create, actually let's create a folder, and we'll just call this test folder 1. So there we created test folder 1 inside the Look at Me folder on the desktop. Now let's close out this console, and the virtual machine is still running. In fact, I'm going to go ahead and go up here and just right click on the virtual machine, and here's another way I can take a snapshot. I can click snapshot from there. Notice it says it's taking a snapshot here. There's 30%, 40, 50, 60. It's happening very fast. There we go, we succeeded. Now we have 2 snapshots. So we have the first snapshot we took here. Below that is the second snapshot that I just took. And then now here's the state of the virtual machine. So let's go ahead and go back in time to the very first snapshot that I took. So I could right click on that snapshot and I could say apply. I could also go over here and I could click apply here as well. Now notice it says, do you want to apply the selected snapshot? I can apply the snapshot, or I can take a snapshot of the current state and then apply it. Now we just took a snapshot, so I don't really need to take another snapshot. Let's just click apply. And notice it says it turned off the virtual machine, it's restoring. This just takes a few seconds. We're doing this real time, no video fast forwarding here, and we succeeded. So now let's go ahead and double click on the console of the virtual machine. I need to sign in again. Let me maximize this window. And here on the desktop, again, there's a folder called Look at Me. If I double click that folder and open it up, well, it's empty. Now, why is that? Because when we took this snapshot, the folder was there. We hadn't yet created that subfolder inside, the test folder that we created after we took the snapshot. So what if I right-clicked here and I said I wanted to, again, create a new folder, and we'll call this test folder number 2. Okay, so let's close this out. And now let's go ahead and go down here, and here's the second snapshot we took. I'm going to right-click on that. I'm actually going to rename it, and I'm going to say that this is with test folder 1. I'm going to right-click on this first snapshot. I'm going to rename that, and I'll say empty folder. And then now let's go ahead and right-click on test folder number 1. I'm going to say I want to apply that. It says, do you want to take a snapshot and then apply it? I'll say, yes, I do. Okay, notice it says it's saving. So first it's taking a snapshot. It said that succeeded. And now it's going back and it's going to then apply the snapshot that had test folder number 1. So here's a new snapshot we just created. If we right-click and rename this, we're going to call this with test folder 2. And I know these are very simple examples, but again, this could be, let's say Microsoft Exchange before installation. You could take a snapshot after installation. Then you could take another snapshot after the installation of Service Pack 1. Then yet another snapshot before, let's say you import 2,000 users. So you take snapshots at different points in time that are critical to you as a server admin or as a developer. All right, so we restored with test folder number 1. Now let's go ahead and double click and open up this virtual machine. There's a folder inside, and it says test folder number 1. Again, super simple examples, but just examples of how this virtual machine state is preserved, whether it's applications that are installed, configurations that are made, files and folders that are created, or even operating system changes that are made. So let's close this out. And again, just for demonstration purposes, if we wanted to right-click on with test folder 2, we could go back and we could apply that. And then I'll go and double-click and open up the virtual machine console. And there we go. There's test folder number 2. So you can see how these snapshots work. They're very simple and easy to use. You can have snapshot trees. So let's say I've got this tree of configuration changes I was testing up here. I could right-click on this snapshot. I could say I want to apply that. Let's go to the snapshot that has test folder number 1. And then I'm just going to right-click on this snapshot, and I'm going to delete the snapshot subtree. However, at this point, there's only that one snapshot there. So it's just going to delete the one snapshot. And there we go. We cleaned up our snapshots. So best practices dictate that you should always try to keep your snapshots as updated as possible, because these snapshots can take up a lot of disk space And you don't want to clutter up your hard drive. You also don't want to, take up a lot of space in your backup files. So that's the basics of snapshots there. Snapshots are very easy to use and extremely useful for administrators, developers, and even application admins. All right, so I just showed you how to create a snapshot, and then I showed you how to revert to a snapshot, actually more than once. We created multiple snapshots, we reverted to those various snapshots, and you saw how they work. Now let's go in and identify virtual disk files that are on the Hyper-V host. So all these virtual machines and their snapshots, where are those located? Well, let me show you. If we go in here to Hyper-V Manager and I right-click on a virtual machine and then go into the settings for that virtual machine, then down to the virtual hard disk, which is underneath the IDE controller. So this virtual hard drive, notice the path, it's C:\users public documents / Hyper-V / virtual hard disk, and then it starts out with the name of the virtual hard disk for this virtual machine. Now, because this virtual machine is currently using snapshots, there's a weird string of characters after the virtual machine hard disk name. However, as you see, when we create a brand new virtual hard disk, it'll just have the name of the virtual machine here by default with, let's say, a -1 or -2 for the different virtual hard disks that you create. You are actually going to set the name when you create the virtual machine hard drive. So let's cancel out here and let's go down to Windows Explorer. And then I'm going to go to the C drive. I'll go into Users, then Public Documents, Hyper-V, and Virtual Hard Disk. So here is by default the virtual hard disk we created when we created this virtual machine. It's just the same name as the virtual machine that was created. Notice that it's only 8.9 gigs in size, or about 9 gigs, so it hasn't fully inflated to the maximum size. That tells me that it's a dynamically provisioned hard drive. Of course, the default size for a new virtual machine hard drive is 127 gigabytes, but they're also set to be, by default, dynamically provisioned or thin provisioned. Now, these other files here that the virtual machine is actually referencing have to do with snapshots. These aren't the actual snapshot files. I'll show you where the snapshot files are located in a minute, but all the virtual machine hard disk will be stored in this folder. In fact, if we create another virtual machine, you'll see here a brand new virtual hard disk file that's created by default, assuming, of course, that you choose to create a new virtual hard disk for the new virtual machine you create. It really wouldn't be that useful otherwise. So if we go back to Hyper-V Manager and we click on the settings for this virtual machine and scroll down to the bottom, notice here it says snapshot file location. So by default, the snapshot files are located in C:\program data Microsoft Windows / Hyper-V, and I can tell you that's the same location that you'll find the configuration files for the virtual machines. So let's go check out that location as well. Again, if we go to the C drive and then into program data, and I can tell you, if you notice, this program data icon is a little grayed out. To be able to see that, that's a Windows system file. You have to go up here to View and over to Options, Change Folder and Search Options. Then underneath View, you have to go down and say Show Hidden Files, Folders, and Drives. I've already done that, and that's why I can go in here to the Program Data folder, then into Microsoft, then into Windows, then into Hyper-V, and here's a folder here called Snapshots. That's where the snapshot files are located. They've got these strange, XML strings here, and then there's some subfolders. Of course, these can grow very large in size, and that's why you don't want to use snapshots any more than you really need to. If we go back a level here, also notice that we have a virtual machines folder. If we go in there, here's the actual configuration file for that one virtual machine currently running on this Hyper-V host. Back here inside Hyper-V Manager, if we click on the Hyper-V server and go to Hyper-V settings, by default, this is where the virtual machine disks are stored. That's the folder that we just browsed to. And by default, this is where the virtual machine configuration files are stored. So that's where you'll find your configuration files, your snapshots, and of course, your virtual machine hard drives. Now, the last task that we had on our list was to add a second virtual machine hard drive to a virtual machine. If we click on the virtual machine, I'll go ahead and just right-click, I'll go to Settings, and I'll go down here to the IDE controller. Notice that if I want to add a new hard drive, that's currently grayed out. That's because this virtual machine is running. I'll go ahead and cancel this. There are some operating systems that you can add new virtual machine hard disks to while the virtual machine operating system is running. I'm not using a version of operating system that supports that right now. So what I need to do is I need to power off, or actually shut down on a production server, this virtual machine. I'll go ahead and turn it off, and then I can go in here to Settings, go down to the controller, and here I can select to add a new hard drive. I'll click Add, and here I have to give it a name of a virtual hard disk if it already exists, or I have to click New and create a new virtual hard disk. So this is the new virtual hard disk wizard. I'll go through here. I'll say I want to use the new format and create a new VHDX file. It's going to be a dynamically expanding virtual disk. We need to give it a name. We'll call it Win 2012-1, and I'll call it Disk 2. Again, by default, it'll be stored in that same location with the other virtual hard disk. I'll click Next here. The default size again here is 127 gigabytes. I could set it to whatever size I want. I could just say 10 gigabytes if I want to. I'll click Next and Finish. All right, there's the path to our new virtual hard disk. All I have to do here is click OK. All right, the virtual machine has been modified. I'll go ahead and start it up. We'll double click it to open the console. I'll maximize the screen here. We'll go ahead and log in. And once logged in, I'll go down here to where the Start menu is. I'll right-click, and I'll go ahead and bring up Disk Management. I'll maximize the Disk Management window. And ta-da, it says it's found a new hard drive. So I'll say OK here to install a master boot record on that hard drive. Notice the size. It says it's 10 gigabytes and it's currently unallocated. I'll go ahead and right-click on that. I'll say I want to create a new simple volume. Just go through the wizard here real quickly. We'll use all the space. We'll assign the drive letter of E. I'll give this volume a name. I'll call it 10 gigabyte disk. I'll click Next here and Finish. Take just a second to format the virtual hard disk. Alright, it says the virtual hard disk has been formatted with the NTFS partition. It is 10 gigabytes and it's healthy. Let's open up Windows Explorer. We'll open up my computer and take a look at this. We've got one virtual hard disk. That's our default C drive. And now here's the new virtual hard disk that we just created. It's about 10 gigabytes. And that matches up with the new virtual hard disk we created over in Hyper-V Manager. There we go. We successfully added a second virtual hard disk to a Windows Server 2012 Hyper-V virtual machine. And what that means is we've successfully accomplished all the tasks here on our list. I showed you how to create snapshots, revert to snapshots, we identified the virtual disk files on the Hyper-V host, and we created a new virtual disk and attached it to a virtual machine. And that brings us to the end of this lesson covering using virtual disk, virtual storage, and snapshots. Thanks for watching.